Okay, ladies and gentlemen, the second installment of Chapter 5, finishing up our discussion of elasticity. These are the questions we're going to look to address in this PowerPoint. First, how is the price elasticity of demand related to two concepts, revenue and expenditure? Then, what is price elasticity of supply? How is it related to the shape of the supply curve? And finally, what are these elasticities we call income and cross-price elasticity of demand? What do they mean and how do we calculate it? Here we go. If you remember from our first presentation, we were talking about you making websites and then considering what price you were going to charge and the impact that was going to have on your business. Well, you were charging $200 and you were thinking about charging $250, and the question is this a good or a bad thing? Well, in microeconomics, what we're going to understand, or what we're going to assume, is that individual businesses operate with one focus, and that is to make as much profit as possible. And profit is very specific. Profit is your revenue minus your costs. So if we say businesses are driven by profit, we need to understand its component parts, revenue and cost. And we want to understand how your choices will affect those two things. So elasticity really helps us understand how our choices as businesses will affect one part of this, that being revenue. So revenue is price times quantity. It is how many units you're selling times the price you're selling them at. That gives you revenue. And when we increase the price of a good, what we are going to find is that it has two effects on revenue. The first one is quite simple. When you charge not $200 but $250, each unit you still sell, you're getting more revenue per unit. You would have $50 additional for every unit you still sell. That would have a positive effect on revenue. But the second effect is built on the law of demand. When you charge a higher price and nothing else changes, you're going to sell a lower quantity. So you're selling fewer units, and that has a negative effect on revenue. The question for us, with respect to what is the net effect or total effect on revenue, is which one of these is larger? Is the positive effect from the higher price for each unit going to outweigh the quantity decrease, or will it be the other way around? And the answer really lies in elasticity. Remember, this is how we calculate elasticity. This is what revenue is. And so we're first going to look at what happens to revenue if we change the price and it's an elastic demand. Well, remember elasticity, price elasticity of demand will be greater than price elasticity of demand. We would describe it as elastic if it exceeds 1. Any number exceeding 1 is relatively elastic. If that's the case, the percentage change in quantity is going to exceed the percentage change in price. So, what if we increase the price? We're going to see a decrease in the quantity, and it's going to be a bigger change in terms of percent than the price increase. So if we are facing an elastic demand curve and we choose to increase the price, you will see the fall in revenue from the lower quantity outweigh the increase in revenue from the higher price. So the total effect on revenue when you're facing an elastic curve and you raise the price is negative. Now, if we did the opposite, if instead of increasing the price, what if we decreased it? If we drop the price, we are going to find more customers come and buy our good or service. And the percentage increase in quantity demanded will outweigh the percentage decrease in the price for each unit. So if we decrease the price and the demand is elastic, total revenue will go up. So here we see a curve. It is elastic in this portion. Price times quantity, we were selling each good at $200. We were selling 12 units. We would generate $2,400 in revenue. We were thinking, remember, about changing the price to $250. Well, look here at what happens to quantity. It drops to 8. So what we find is this is subtracted from our total revenue. There were 4 additional units we used to sell but are no longer. Each one we were selling at $200. So we have a negative impact on revenue to the tune of $800. Remember though that we gain something. Up here we gain $50 extra for each unit we still sell. $50, we have 8 units, that's a positive 400. But a positive 400 is outweighed by a negative 800. The total effect is negative to the tune of $400. And just like we analyzed this from an elastic demand, we're going to do the same for inelastic. If demand is inelastic, then the elasticity reading is anything less than 1. In such a case, the percentage change in quantity is less than the percentage change in price. The fall in revenue when we, the fall in revenue from the lower quantity that we're selling, because we remember we're looking at increasing the price. So if we increase the price, we're going to decrease the quantity sold. But the fall in revenue from the lower quantity sold is actually smaller than the increase in revenue from the higher price. So total revenue will go up if we're facing an inelastic demand and we increase the price. Just as we did with the previous one, we could work the other way with price. If we decrease the price and we have inelastic demand, that means we don't have price-sensitive consumers. We're going to find that we entice a few more people to buy our good or service, but the percentage change in quantity will not exceed. It will be less than the percentage change in price. Therefore, the impact on total revenue will be negative when we drop the price and the elasticity of demand is negative. Okay? So, here we have our inelastic demand, it's 0.8. We have our data, revenue is 2,400. Now we increase price and it's inelastic. We find we're selling each unit for $250 as opposed to $200. This is all gained up here. So we're still selling 10 units, and for each unit, we're getting $50 extra. 10 times 50 gives us a positive 500. Remember, there is some loss, so we come over here and we see that. All right? We're losing out on $200 per unit, and we're losing out on 2 units. 2 times 200 gives us 400. So that's negative, this is positive. The net effect is a positive $100 increase in total revenue. And again, that's because it's an inelastic curve and we increase the price. Okay. Here's a couple of thought experiments. You can look at these and then answer them yourself. So pause the video, answer them, and then here are your answers. You can check your work. If pharmacies raise the price of insulin, we're going to see total expenditure, which is just from the consumer's standpoint. Revenue is from the business's perspective. That's what they call it. All the money's coming in, they call revenue. From the consumer standpoint, we call it their expenditures. Expenditures will rise because people are pretty price insensitive to insulin. They need it as a necessity. They can't treat their diabetes in any other way. And so, because it's a necessity, they are really at the mercy of these pharmaceutical companies when they raise their price. It just means consumers are going to be spending more money on that same good. Okay? Expenditure is going to rise. Now, if we talk about cruise lines, it says the result of this fare war means a 20% reduction in the cost or price of a luxury cruise. How is that going to affect total revenue? Well, hopefully we're able to say that that's actually going to increase total revenue. Because luxury cruise, those things are elastic. Those things are certainly not necessities. There's a lot of other ways to entertain yourself. When we have a fall in price, we're going to see people respond to it. And so the percentage increase in quantity demanded will exceed the percentage decrease in the price, and total revenue will actually go up. Okay? So we'd say revenue rises again. Now, what we do is we're going to move on to price elasticity of supply, and it's going to be really simple. All it does is just flip the perspective. We're now talking about producers' choices and how they respond to changes in price. It's the exact same formula, we're just taking the percentage change in quantity supplied as opposed to the percentage change in quantity demanded. Putting it again over the percentage change in price. We're talking about sellers' sensitivity to price as opposed to buyers' sensitivity to price. And we're going to use the midpoint method to compute our percentage changes. We look here, we see an upward sloping supply curve, as it should be. As the price increases, producers' willingness and ability to produce more increases. We got an 8% rise in price. What does that correspond to in terms of quantity supplied? We see a 16% rise. Hopefully you're able to sit with this and say, I know what type of elasticity that is. You would say that's a relatively elastic response, because 16 over 8 is 2. Anything greater than 1 is a relatively elastic response. And just as we had 5 curves for price elasticity of demand, we're going to have the same for supply. The slope of the supply curve is going to be very much related to the elasticity. Just as with price elasticity of demand, the flatter the curve, the bigger the elasticity, the more response. The steeper the curve, the more insensitive, the smaller the response. 5 different classifications. Here we go. Vertical line, what that means is we have a 0% change in price with whatever change, 0% change in quantity over whatever change in price. Vertical lines always mean perfectly insensitive consumers, or in this instance, producers. Okay? Anytime you get an elasticity of 0, it's perfectly inelastic. Now we start to see a little bit more sensitivity, but it's relatively low. We have a 10% increase in price, and we have a less than 10% increase in quantity supplied. We would describe this as relatively inelastic, or producers who are relatively insensitive. An intermediate slope, when we have a 10% rise in price, we get a 10% increase in quantity supplied. That is units elastic when it's 1. We move on and we start to see it again flatten out. The flatter it gets, the more elastic it gets. The price sensitivity is quite high. So elasticity, we take the change in quantity supplied, it's greater than 10, over 10. It's going to give us a number that exceeds 1, and anything that exceeds 1 is relatively elastic. And our last one, if we have a perfectly horizontal line, we are saying producers are infinitely responsive here. The elasticity is infinity, that would be your reading. In such a case, we would describe this as perfectly elastic. The more flat, the more elastic the curve. Now, just quickly, we're going to talk about the determinants of the supply elasticity. Just what determines the shape of that curve? What determines whether producers are going to be responsive? That's all we're discussing here. It says the more easily sellers can change the quantity they produce, the greater the price elasticity of supply. So imagine this. What if you had a factory and it was producing at 10% of capacity, and the price increases? Are producers capable of increasing production to meet the needs at that higher price? And the answer would be yes. But what if they were producing at 100% capacity? Their factory was turning out as many products as they could, and the price increased. Would you see a lot of sensitivity there? And the answer would be no, because you would need time to construct a new factory to then increase the production. So there's not a whole lot of sensitivity when you're almost at capacity. But there's great sensitivity when you're at much less than capacity. So the example here, we give one called beachfront property. So beachfront property, we can't create really new beaches. So beachfront property, the supply of it is really inelastic. So it's much more inelastic than, say, the supply of new cars. We can ramp up the production of cars probably in response to increases in price. But it's very difficult to create new beachfront property despite those increases in price. So it says for many goods, price elasticity of supply is greater in the long run than in the short run. And that really applies to what I said earlier. If we're looking at a long run perspective, well then higher prices are going to translate into greater quantity supply, because a long time gives people an opportunity to build new factories, expand their existing ones. New firms can get started in response to that price increase. So the greater time, the more elastic the supply curve. All right, our last two topics here, income elasticity and then next cross-price elasticity. When we look at income elasticity of demand, what we're doing is we're measuring how responsive consumers are, not to a change in the price of that good, but to a change in their income. Right? The formula that we're going to use to create or to arrive at income elasticity of demand is the percentage change in quantity demanded over the percentage change in income. So let's say you get a raise of 5%. You have a 5% increase in income. What then is going to happen to the percent change in your consumption of a particular product? That's what we're studying here with income elasticity. So it says, recall from chapter 4, an increase in income causes an increase in the demand for what we'll call normal goods. So what we are actually going to do here with income elasticity is be able to categorize goods that are normal and inferior. These are our two categories of goods. And with normal goods, there will be a positive relationship between income and your consumption. If your income rises, your consumption will also rise for normal goods. So that's one category. If your income falls, your consumption will fall for normal goods. That's how we classify them as normal. It's actually the response in terms of consumption to a change in your income. That's how we call it a normal good. And then inferior has an inverse relationship. So an inferior good is classified or is identified when we see an increase in your income and you actually buy less of those goods. Or if there is a decrease in your income, you actually respond by buying more of those goods. Those goods where you have a rise in your income and a fall in your consumption, we call them inferior. Okay? So for normal goods, income elasticity will be greater than 0. The reason is that there's a positive relationship. So income elasticity of demand. Let's say we're talking about cars. We see a 10% increase in the income of all individuals. What will happen to the consumption of cars? Cars, for most people, are normal goods. They buy more when they have greater income. So you would see maybe it's a 2% increase in the quantity demanded for cars. When 2 is divided by 10, gives you 0.2. 0.2 is a positive number. It is greater than 1. Anytime you get an elasticity rating of greater than 1, that good is a normal good. Most goods are normal goods, but not all goods are normal goods. What happens if we see a 10% increase in your income and you have a, 2% drop in your consumption of that good? What type of good might that happen? Maybe it's bus rides. Bus rides are a good, oftentimes, or a service that's rendered to us. We don't usually think of that, but think of bus rides. A lot of people, I don't want to judge here, but some people ride the bus because they're green. They want to be environmentally conscious. They'd like to ride with as many others and reduce their carbon footprint on the world. Others are simply riding the bus because it's a cheaper alternative to owning a car themselves. So when there's a rise in income, and we assume that people will buy more cars, people think cars are more convenient than the bus, they will buy more cars with the greater income. And if they're buying more cars and more people are using those cars, there's less ridership for buses. So the rise in income will actually translate into a fall in bus rides. It would give you a 2% decrease and a 10% increase. This would be a positive number. This would be a negative number. So you would have negative 0.2 as your elasticity. Anytime we see an elasticity reading that is negative, less than 0, we know that good is inferior. And bus rides are one good that is inferior for most people. And the last slide here, we have cross-price elasticity. What we're doing here with cross-price elasticity is determining the relationship between goods. Are goods considered substitutes or are they complementary? So it measures the response of demand for one good when the price of another is changed. So what we do to figure it out is we take the percentage change in quantity demanded for good 1 over the percentage change in the price of good 2. I'll give 2 examples and hopefully this will illustrate things. Let's talk about hot dogs. No, let's not do hamburgers. Let's keep it simple. Let's do hot dogs and ketchup. How are hot dogs and ketchup related? For most people, if you're not the little kid from Big Daddy, or you're not like my niece, ketchup is not something you consume by itself. You don't say, hey mom, dad, can I have 30 packets of ketchup for dinner tonight? Most people don't do that. But they might say, hey mom, dad, where is the ketchup? Because you're having hot dogs and you don't just eat a plain hot dog, you only eat hot dogs with ketchup. These are complementary goods. So what happens if there is a 10% increase in the price of ketchup? We'll call that good 2. What then is going to happen to your consumption of hot dogs? Well, remember that you eat hot dogs and ketchup together. Not in isolation, but together. So if you have a 10% increase in ketchup, fewer people will be buying ketchup. And therefore, fewer people will be buying hot dogs. So I don't know what the percentage change is. Maybe it's a 2% decrease in hot dog consumption with a 10% increase in the price of its complementary good, ketchup. Regardless, the number you get is negative. Anytime you get a cross-price elasticity that is less than 0, it is a negative number. You know those goods are complementary. But that's not the only relationship we have between goods. We also have substitutes. So let's talk about Coke and Pepsi. I know for a lot of people, Coke and Pepsi are not substitutes. I'm not saying that they have to be substitutes for you. I'm just saying some people think that you might be able to replace Coke with Pepsi. So don't get all heated. So what happens if, in a hypothetical situation, the price of Pepsi goes up by 10%? What would you then expect to happen with the consumption of Coke? Well, hopefully you're reasonable enough to say some people will switch from Pepsi to Coke. You will see an increase. Maybe it's a small one, maybe it's a big one, I don't know. But it's going to be a positive response. More Coke consumption is going to be seen. So the 2% increase in Coke consumption over the 10% increase in the price of Pepsi is going to net you a positive number. Anytime you get a positive number, anytime it exceeds 0 with the cross-price elasticity, those goods are substitutes. And, ladies and gentlemen, that's my presentation. These are the summary slides. I'll flip through them. I'll stop. You can pause it. Take a look. A couple other summary slides. Pause it. Take a look. Internalize. I think we have 2 more. No, excuse me, last one. Take a look, internalize, come in tomorrow, prepare to work with the material. That's all, folks. Go fill out the response form. Hope you enjoyed Elasticity.